let's talk about future value. Now, the future value of a series of cash flows is the value of those cash flows themselves, so the money that you put into the account every month or every year, plus the interest that those cash flows earn by sitting in the account, right? So we're going to use the future value when the question asks, well, how much money will be in the account at some point in the future? Now, here we've got a visual representation of what this looks like. So this is our first timeline. You're going to see many today, right? Where these are the cash flows. So that's money that we're putting into the account. And the future value is all of these amounts added up plus the interest that those earned, right? So this guy plus the interest that he earns over however long that period is, that's going to be what goes into green, and that's going to happen for each and every one of them. So it's pretty amazing that we can actually take one formula and do one calculation and find, well, the sum of all of these cash flows and the interest, which I think is cool. So then next up is the present value. Now, the present value of a series of cash flows is the cumulative value today, right, of cash flows that happen in the future. So it is obtained by discounting each cash flows. In other words, we're working backwards by removing interest. So the value today, or the present value, is basically the amount that we have to invest or put away today so that tomorrow or a month from now or whenever this cash flow is happening that we're talking about, so that that money that we put in today can accumulate to that amount. So if we're moving forward in time, generally amounts get bigger because they're gaining interest. And when we're moving backwards in time, we have to discount, we have to remove interest so that the amounts themselves get smaller. Okay, so we're going to use present value when future payments have to add up to a certain amount today, such as the amount owed in a loan, right? So when you take out a loan, you know exactly how much money you owe today. You go to the bank, you say, what do I owe you? They say R1,000,000, you cry, and then you know exactly what you owe them, right? But those payments are going to happen in the future. But it only makes sense that the payments that you're going to make have to in some way equate to the loan amount that you're going to pay, right? So that loan amount is the present value of all of the payments that you need to make in order to pay off that loan, right? So it's taking each of those future cash flows and removing interest, working backwards in time in order to find the value today of those cash flows. So there's some T's and C's. Now, the rules for annuity formulae are: the annuity formulae are for annuities in arrears. Now, there are formulae for annuities in advance, but those aren't on your formula sheet, so we're not going to worry about those. But what on earth does it mean to say in arrears? Now, in arrears means the first payment is on T1, which means it's at the end of the first period. So here, T Nought is where we're starting, right? T1 is at the end of that first period. So if we, for example, make monthly payments, right, in order to use the formula without adjustments, those monthly payments have to happen at the end of the month. If you're going to make annual payments, in order to be able to use that without adjustments, those annual payments have to happen at the end of the year, right? So that's annuity in arrears, right? And that's, again, the assumption that we have to make if we're going to use the annuity formulae as they appear on the formula sheet. Number 2, the final payment happens at Tn. Now, Tn is the end of the period over which the annuity is calculated, right? So if you are doing a present value annuity, well, Tn will be the day on which the final payment takes place. And for a future value annuity, Tn is going to be that day on which we are trying to find the value of all of these cash flows, that future value. And then the last one is that everything has to match up. So the frequency of the payments, the frequency of the compounding period, and the n all have to correspond. Okay, so what does that mean? So here, if we've got this formula, present value equals x, 1 minus 1 plus I to the negative n over I, right? If those x's, those payments are monthly, then the interest rate has to be one that is compounded monthly. And the n then has to represent the number of months. Okay, so those three things have to agree. If x is monthly, the n has to be number of months, and the interest rate has to be compounded monthly. Very important. Okay, so let's talk about payments at T Nought, right? So we said that one of our implicit assumptions that goes with the use of the formula is that the annuity has to be in arrears. The payments happen at the end of the period. Now, sometimes that's not going to be the case. We're going to have a payment that is made on day one, which now is a bit of a pickle. So let's see how we deal with that. So there's only two principles to remember for this, one for present value, one for future value. So for present value, the idea is going to be that you treat the payment at T Nought as a deposit. Right, so what's a deposit? Well, a deposit is money that you pay upfront on the day, T Nought. So for example, if you buy a house, usually you'll have to put a deposit down because not many banks are that keen on giving you a 100% mortgage. So then the future value has a very easy solution. We're just going to add 1 to n. So let's see how this works. So we've got John, and John is going to deposit money into an account starting on the 1st of January 2020. Okay, so I've already got a T Nought. I'm going to call it there, T Nought, right? And this is 1st of J 2021, okay? Right, and then he makes monthly deposits into this same account at the end of each month, right? Including 31 January 2020 up until 31 December 2020, right? And it says the interest is earned at 10% per annum compounded monthly. Okay, so he starts, and we have an account starting on this 1st of January here. Okay, now what's very important is that we know how much money John puts into the account. And whoever the brilliant person is who made these slides didn't put that there. So let's say that he puts 1,000 Rand into the account each and every month. Okay, so at T Nought, he puts in that 1,000 Rand, okay? And then we know that this goes on until 31 December 2020, okay? Right, I put 2021 here, got to be 2020, right? Okay, so a year is going to be 12 months, so this is going to be from T Nought to T12, and that then here is going to be our 31 December 2020, right? And then on each of these end of the periods, we know we're going to get 1,000 Rand payment. So 1,000 Rand here, right? 1K here, 1,000 Rand here. I'm writing 1K because I'm lazy. And then here we're also going to have 1,000 Rand. Okay, so in terms of our annuity formula, right? We know we want to do a present value calculation. So we're going to start here with present value, so PV. Okay, so then we've got to say, well, what is X? So X is the payment, so that's going to be 1,000. So that's our X. Right, then we've got 1 minus 1 plus, and now the interest rate is this 10% per annum compounded monthly. So we've got to take that 10%, and remember, when you put this 10%, you've got to use that percentage thing on your calculator, otherwise your calculator doesn't know that you mean percent, and then you're going to get a weird, wacky answer. So use the percentage, or just write it as a decimal, 0,1. Okay, whatever you prefer, I'm going to do the percent. So 10% over 12 to the power of negative n. Right, now here we've got to count how many periods we have. So we'll have 1, 2, 3, and that's going to go all the way up to T12. So this negative n is going to be negative 12, right? And then we've got to divide by the interest rate, right? So the interest rate we've got is 10% over 12. Okay. Now, what we've got to remember is that this formula was for the annuity in arrears. In other words, it's taking into account the payment at T1, at T2, at T3, at T12, etc. All of these payments, but it's not taking into account this 1,000 Rand payment that he put down as a deposit. However, it's not a problem because money today is money today. It doesn't need to be adjusted for interest. So we're just going to add it on as a deposit. So that 1,000 Rand here, we're just going to add on. So plus 1,000, we're treating it as a deposit. And then all we have to do is put that into a calculator and then see what we get. Right, so that's the easy part. I'm not going to do that because I'm sure we all know how to use a calculator. Right, so then let's see here. John deposits money into an account starting on the 1st of January 2020. He then makes monthly deposits. Wow, I'm having deja vu. Oh yeah, it's the same question, but we need to calculate something else. It says we've got to calculate the future value of the amount on 31 December 2020. Okay, so now we're dealing with future value, right? So our timeline is going to look the same, right? It's going to start at T Nought. We said that John has 1,000 Rand that he can put in every month. This goes to T12, and we have R1 that goes into the account every month. But again, we're going to start at T Nought because he put money into the account on 1st of January 2020, and then at the end each and every time. Okay. So, because we have 12 periods, usually what we will substitute in to the FV formula, the future value formula, would be that 12, that number of periods, right? But now we have a payment at T Nought, which is not usual. So, how do we deal with it? Well, for future value, it's really simple. We just add 1 to n. So technically, yes, there's still only 12 months, 12 periods, but because there are 13 payments, we're just going to add the 1 to n, and it works, right? So here, if we use our future value formula, our x is going to be the 1,000, right? And now we've got to go the 1 plus, and again, we're going to go 10% over 12. And then here, the n is the interesting thing, as I said, because it's going to usually be 12 for 12 periods, but we have a payment on T Nought, which means we just add 1 to the n. So this is then going to be 13 rather than 12, and then the rest is just substituting in. Okay, so then you get the 10% over 12. Life's good, you put it into your calculator and you can feel good about your achievement. Okay, so then what we're going to do is figure out what happens when the other assumption is violated, this idea that the final payment has to happen on Tn. Right, now this isn't a problem at all for the present value because the present value is working backwards. So if things happen after Tn, well, it's not your problem for present value. But for future value, it is a bit of a problem if your future value is after the final payment. So what are we going to do? Now the principle is find the future value on the day of the final payment and just grow that amount using the compound interest formula from the day of the final payment up until Tn, which is the end of the period where we want the future value. Okay, so we've got John. He's been very busy of late. He opens a bank account 1st January 2016. He makes quarterly payments into the account starting on 31 March 2016. Is that the end of the quarter, January, February, March? Yeah, that's at the end of the quarter, so we're in arrears, that's working. And ending on 31 December 2018, interest is earned at 6% per annum compounded quarterly. We have to calculate the amount in John's account on 31 December 2020. Right, so we're going to start at T Nought. Okay, and T Nought is going to be that 1st of January 2016, and we know that our annuity is going to continue all the way up until 31 December 2018 with the payments in arrear. Now, if we started 1st January 2016, we end in 2018, that's 2 years. How many quarters are in 2 years? I would say probably 4 times 2 is 8. There's 8 quarters. So our annuity happens up until T8, right? Which is our 31 December of 2018. right? And this is when our final payment takes place. Now again, some smart person didn't put the amount here. They just say they pay 1,000 Rand each time. So here's our 1,000 Rand at T8, right? And this one played along with our other assumption that it's in arrears. He didn't make a payment on the 1st of January 2016. He's merely opened the account. He makes his quarterly payments into the account starting on 30 March 2016. That's at the end of the first quarter, so that's going to be at T1. And if your first payment is at T1, life is going to be dandy, because that means you'll have 8 periods for 8 quarters, and you're going to have 8 payments, right? So the future value of all of this, right, is going to be that 1,000, right, times, and now we need the 1 plus the I, what we have, 6%. So 6%, this is now quarterly over 4, right? And this is now over 8 periods. So this is to the power of 8. And then we've got our minus 1. And we divide this by the 6% over 4. Fantastic. Okay, now this gives us an amount of money that's going to be in the account here at T8, which is the 31st of December 2018. But now the issue is we want to calculate the amount in the account on the 31st of December 2020. So he stops making payments and the money just sits there. But the nice thing about money is that if it just sits there, it's not doing nothing. It's earning you interest. So here, if we go to 31/12/2020, well, that looks like it's an additional 2 years, right? So that's going to be an additional 8 periods. So that's T8. I'm going to call this T16 for consistency, right? And then we know that we've got to take this amount that we had here and grow it using our normal compound interest and find out, well, how much is it on the 31st of December 2020 after those 2 years, right? So what we're going to do is we're now going to calculate this future value. And that future value we know is going to be the amount in the account at T8 for 31/12/2018. So let's do this. 1,000 times the thing. All right, and then we've got to raise this to the power of 8 minus the 1. And we've got to divide by the interest rate. Okay, right, so I get here that the future value, the money at T8, is going to be this 8432,80. Okay, that seems reasonable and realistic. And so the final amount is going to be that, which is this here, which grows for another 2 years at compound interest. Now again, this period isn't an annuity because the money is just sitting there earning interest. We're not paying additional funds into the account. So now we can just say that accumulated amount at T16 is going to be the principal amount. That's the 8432,80 times the 1 plus the 0.06 over 4. Right, and then that's again going to be a further 8 periods. That's 8 quarters over the 2 years. All right, and that's then going to give us an answer. Let's see what we get here. Okay, so I get that this is going to appreciate nicely, and when he goes to the bank, they're going to give him good news. He has 9,499 Rand and 50 cents in the account. Okay, so that's how we deal with the final payment not being on TN. We just find the future value up until the day of the final payment, and then we take that amount and we simply grow it using our compound interest formula. Fantastic, let's keep going.